I'm Anil Kumar sharing with you some questions from my subscribers who are actually preparing for IIT JEE or in university. I thought I'll modify the question a bit and make a video which is useful for most of my viewers. We need to actually find derivative of some absolute functions listed here. They are kind of complicated. But before getting into this detail, I would like to discuss and understand absolute functions, how they are related with Signum function and square root of x squared, and then we'll get into the derivatives of absolute function. I hope you find this approach interesting and useful. Let's begin with the absolute function. When we say absolute x, we are trying to say that it is x when x is greater than or equal to 0, minus of x when x is less than 0, right? We also represent absolute functions in the form of a graph. If you have a line y equals to x, let us say, in that case, absolute function is always positive. So this is what we mean, right? So when we say it is x when x is greater than or equal to 0, s minus of x means it gets reflected kind of like this. Do you see that? So that becomes the left arm of an absolute function, right? So that is the absolute function. Now, one of my very successful video is what is square root of x squared. Now, square root of x squared, many students will say just x, but remember, it is always positive, right? So we know it is always positive. And how can you make it always positive? If you have absolute value. Perfect. So that is important to remember, that absolute value of x is actually square root of x squared. And we can actually use this to find derivatives. To find derivatives, we could also use the graph as a piecewise function. Do you see that? Another important function is Signum function, which we say, in short, we write SGN, Signum x, which is basically equal to minus 1, 0, or 1. If x is negative, that is less than 0, it is negative. If x is 0, it is 0. And if x is positive, that is greater than 0, then Signum function is positive. Now, how are these two related, absolute and Signum? That is very important to understand. They are related like this, that we could say that x over absolute x is basically Signum function, right? Where x is not equal to 0. Perfect. So if I divide x by x, I get 1, minus x by x, I get minus 1. So I kind of get Signum function without this 0, so that is the restriction. Well, I could also write this as absolute value of x over x as Signum function, right? So both are valid. So I hope you get an insight to some very interesting functions which can help you understand absolute functions, right? So I'd like you to actually go back, rewind, and understand what all this is about, okay? And then we'll actually begin with derivatives of absolute functions. So I'll take up the very basic derivative first, which is f of x equals to absolute x. The second one is similar, so I clubbed them together, right? So let's look into the absolute function in different ways. First, you saw that absolute function could be represented as a piecewise function, right? So if I'm saying that f of x is equals to absolute x, which is equal to, let's say minus x, minus x when x is less than 0, equals to 0 for x equals to 0, and plus x when x is greater than 0. In that case, the derivative should be what? Derivative should be derivative of these, right? So minus 1, 0, and 1 if x is less than 0, if x is equal to 0, and if x is greater than 0. Straightforward, correct? It should be like this. But really speaking, what happens is that if you look for the derivative at 0, then what do you see? If you are approaching from this side, it is negative, right? But from this side, it is positive. So we say, well, this particular part is not defined. As approaching from different sides, you get different value. Another way of looking into it is like this. Here, this point is a corner, right? And we know at corner, derivative is not defined, right? So, does not exist, let us say. Is it okay? So basically, what we say here is that the derivative of this function could be shown as, let me show you, as like this. On this side, it is -1. On the other side, it is +1, but not defined at 0, right? So that is the derivative of absolute x. Does it make sense, right? So you could do, with the help of a graph, explain and find your answer. Alternate method is, let's do alternate method. We'll actually define absolute x as square root of x squared, right? You know, absolute x is square root of x squared. So what is the derivative of square root of x squared? Well, the derivative of square root of x squared is, you could treat this x squared to the power of half, right? Which is half. X squared to the power of minus half times derivative of inside function, which is 2x. So this cancels, right? This cancels. And what do you get? What do you get? Let me write it on the right side. Let me write it on this side. So what you get here is that the derivative of, let me write dx of absolute x, right? Derivative of absolute x is x over square root of x squared, right? This is what you get. But you know, square root of x squared is absolute x, so I could write this as x over absolute x. So we get derivative of absolute x is x over absolute x. And clearly, here the restriction is that x is not equal to 0, right? So that becomes the derivative of absolute x. Does it make sense, right? Now look here. Now this value, x over absolute x, could be written as signum, right? It is a signum function, right? X over absolute x is signum function. So what you also notice here is that the derivative of absolute x is signum x. Since this value, you can see, is +1 when x is positive, -1 when x is negative, where x does not equal to 0, right? So basically, it is, as you can see, either +1 or -1 when x is greater than 0 and when x is less than 0. So derivative of absolute x can be written as signum x. You get an idea, right? So that is the derivative. You could write in this form also. So using this form, you can now write down derivative of g of x. So let me write down the answer here and let it be an exercise for you. You could either sketch and then find the derivative, or you could write this as absolute value of x minus 2 equals 2, x minus 2 whole square divided by, square root of x minus 2 whole square. Does it make sense to you, right? So you could write this as x minus 2 over absolute value of x minus 2, or this could also be written as signum x minus 2. Do you get the idea, right? So the derivative of g of x is signum x minus 2 when you write g of x as absolute x minus 2. Does it make sense to you? Just as we wrote here. Now this is huge application, right? So let's continue, and I hope you have understood the concept. So let's take up this one now, which is we know h of x equals to absolute value of x minus 5 to the power of 4. So if I have to write derivative of h of x, I'll apply the power rule, which is 4 times absolute value of x minus 5 to the power of 3 times d dx of absolute value of x minus 5. And now I know that the derivative of this function is what? Is signum x minus 5. Does it make sense to you? Right? So we just derived it. Perfect. So that's a very interesting way of finding it. I hope you find it interesting. Well, here are a few other approaches which you could adopt. Now, if you see, strictly speaking, you could also write h of x as equals to absolute value will mean always positive, right? Always positive, right? So I could also write this as x minus 5 to the power of 4. Does it make sense to you? X minus 5 to the power of 4. Now if I do that, then I write that the derivative is 4 times x minus 5 to the power of 3 times derivative of x, which is 1. Which is 1. That means basically I get my result as 4 times x minus 5 whole cube. Right? So that means what? That suggests that we are going to get a positive value always of this particular function. Right? And it is going to be 4 times x minus 5 whole cube. Let's look at in a different way. Okay, so let's say like this. I'm saying that x minus 5 is kind of a graph like this. Right? And yes, I forgot to tell you that when we did this, we know x is not equal to 5. Is it okay? So it is not defined at 5. There's a corner there. Now this is x minus 5, and if I do to the power of 4, that is a restriction, a corner, right? So here we know x is not equal to 5. Well, let's get back to this once again. Okay. The derivative here, which we wrote like this, could also be written as 4 times absolute value of x minus 5 whole cube, and this could be written as x minus 5 over absolute value of x minus 5. Correct? Which I wrote as signum. Now that clearly indicates that x is not equal to 5. Is it okay? So let's get back to the original derivative to give you an idea. So let's get back to this page once again. We wrote that the derivative of absolute x is x over absolute x, where x is not equal to 0. Is that clear? We wrote that derivative of g dash x is x minus 2 over x minus 2 absolute value, and of course I should have written x is not equal to 2, right? The denominator is not defined. So at this stage, wherever we have this corner, derivative does not exist. Does it make sense, right? So keep that in mind as we move along. Perfect. So let's get back to this. So the derivative of this function basically is that function. Applying the power rule, writing the derivative, and here you can very clearly see that x minus 5 is in the denominator, and therefore it cannot be equal to 0. Is it okay? Now some of you could simplify this. So you could simplify and write like this, that one of these get cancelled, so we get 4 times absolute value x minus 5 whole square, right? Whole square times x minus 5. Is that okay? Now x minus 5 whole square is as good as x minus 5 whole square, right? So I mean the absolute value, right? So you could also write this as x minus 5 whole square times x minus 5, which is 4x minus 5 whole cube. So I hope that makes sense to you. So now you can see in different ways we could actually write derivative of this as 4 times x minus 5 whole cube. Do you get it? So when it is a power of 4, we could always consider this to be, it is always positive force, right? So it could be treated as x minus 5 to the power of 4. And you could easily find the derivative as we have shown here. Perfect. You could also write a result in terms of Signum function as we have mentioned here. Right? And what we also learn here is that the absolute value of x squared is x, right? So that is a reminder, lesson note. Since we know absolute value of x is equal to square root of x squared, in that case, tell me, what is square of absolute value of x? It is x squared, right? So this is what I'm doing. I'm writing here, if you look into these steps, let me highlight it. If you look into this portion, I'm writing absolute value of x minus 5 whole square as x minus 5 whole square, and that is how they are related. Does it make sense to you? So this is a very important aspect to think about whenever you're working with absolute functions, right? Now, as we took this derivative, we knew that x minus 5 came in the denominator, and therefore we have a condition that x is not equal to 5 for all this, right? So the answer is this. So the answer is this, where x is not equal to 5. So I hope this is absolutely clear. Okay, so it's kind of tricky, but that's how we need to see it from different angles and understand, right? Okay, so let's move on and take up the next question, which is to find the derivative of the function, the quotient of x minus 5 divided by x minus 5 absolute value. I'd like you to pause the video, answer, and then look into my suggestions. So here is a very interesting question. We need to find derivative of p of x, which is x minus 5 divided by absolute value of x minus 5. Now what is this function equal to? Well, if you go back to what we learned, let me share that again with you. The very first page where we talked about Signum function. We know that Signum function is the ratio of these two, correct? Okay. We'll now approach in many different ways to answer this question. First, of course, is graphical approach. So if I have to sketch the top part of it, which is x minus 5, that means we are talking about a line which has slope of 1 and y-intercept of minus 5. So let's say that is the line, right? So this is x minus 5. Okay. Now the other line here we're talking about is absolute value of x minus 5. So absolute value of x minus 5 will be kind of like this. Right? So this is absolute value of x minus 5, where of course this point is 5, right? Now the idea is, what is p of x? Now p of x is x minus 5 over absolute value of x minus 5. As you can very clearly see, we cannot have x equals to 5 since the denominator cannot be 0. So this point is kind of a hole, right? Now, if I divide red by green, what do I get? At this point, I get 1, right? And if I divide red by green, their magnitudes are same. In that case, I get minus 1. Since their signs are different, one is positive, one is negative. So what I get here is either a value 1 or minus 1. Is it okay? So I could write this as Signum x, where x is not equal to 5. Is that clear? Well, as a piecewise function, you could write this as -1 or +1. When x is less than 5, it is -1. When x is greater than 5, it is +1. And therefore, the derivative of this function will be either equal to 0, either case, right? Both are constants. Both are constants. And therefore, we know that the derivative of this function is equal to 0, except at x is equal to, not equal to 5, right? So, only at 5 it is not defined. However, this derivative is 0 anywhere else. Is that clear to you, right? So what I would like you to do is, let's say alternate method. Alternate method could be using quotient rule. So we can say that derivative of the function is, let us say, absolute x minus 5 whole square. Now x minus 5 derivative is 1 times absolute value of x minus 5 minus, we could write here x minus 5 times the derivative of absolute x, right? So derivative of absolute x is x minus 5 over absolute x minus 5, correct? That is what we learned, right? So let me again show you. It's kind of very important to understand how we get to this, This is from here, x over absolute x, which is signum x, right? Okay. So in that particular case, if I take absolute x minus 5 as a common denominator and multiply, I get absolute x minus 5 whole square minus, we get x minus 5 whole square. Let me write this as 1 over absolute x minus 5. And here we have absolute x minus 5 whole square, right? Now what is this? Well, when we square, both are same, right? So we know this is equal to 0. Since you know that absolute value of x minus 5 whole square is actually equal to x minus 5 whole square, right? Because of this. Do you see that? So in any case, any approach you follow, what you get is that this derivative is equal to 0, right? So we get p dash x equals to 0, but x should not be equal to 5. It is not defined at 5. Is it okay? It does not exist at 5. Is that clear to you, right? So these are different approaches which you could adopt to answer your question. Is it okay? So I think the easiest of all is kind of splitting them into piecewise functions and do it. That is the most complicated approach, right? Avoid, I should say. And remember, the square of this is equal to square of x minus 5. Is that clear? Now with that, let's get to the real question, which is a high-level derivative. A difficult question on derivative of absolute functions. You need to find derivative of p of x, which is x minus 2 to the power of 5 divided by x minus 5 to the power of 4. I'd like you to pause the video and answer this question at this stage. This has been posted by one of my subscribers who is probably preparing for IIT JEE. Let me thank all of you for participating actively and posting such good questions. We need to find derivative of p of x, which is equal to x minus 2 to the power of 5 divided by x minus 5 to the power of 4. Now to begin with, let us write them as a piecewise function. So what we can do here is that we could write x minus 2 absolute value to the power of 5 as equal to. So we could write this as minus of x minus 2 to the power of 5 when x is less than 2, or x minus 2 to the power of 5 when x is greater than 2, right? So let me for the time being take this less than equal to. As far as absolute value of x minus 5 to the power of 4 is concerned, now if I do negative, then since this power is 4, it is going to be always positive, right? So this function basically is x minus 5 to the power of 4 for all values of x, right? Well, for some of you, if this concept is not very clear, let's get back to the absolute value of x, which is equals to square root of x squared, right? Then what is square of absolute value of x? It is going to be x squared. You get an idea, right? So if we have even powers, then it would be kind of similar situations, and therefore I could write like this. Is that clear? Right? Okay. We also learned that the derivative of absolute value of x is x over absolute value of x, where x is not equal to 0. Right? So all these derivatives are defined at all the points except for wherever there's a corner, right? So straight away we know for these functions that x is not equal to 2 or 5. Is it okay? That is a point where derivative is not defined. Okay. So that leaves with a situation in which basically we are working with two functions. If you see, right? We have first function for x less than 2, the other one when x is greater than 2. And the function here, when less than 2, could be defined as minus x minus 2 to the power of 5 over x minus 5 to the power of 4. Is it okay? And the other one will be x minus 2 to the power of 5 over x minus 5 to the power of 4. Right? So let's call these functions as f of x and g of x. Right, so I'll split this function into two parts where x is less than 2 or greater than 2. We clearly know that it's not differentiable at x equals to 2 or at 5. Is it okay? Now the idea is that both are very similar functions except for this negative sign. So we'll work with the derivative of this function, right? So we can write this as g of x equals to x minus 2 to the power of 5 over x minus 5 to the power of 4. Now, it's a simple quotient rule, right? So this implies that the derivative of this function should be equal to denominator square, which is x minus 5 to the power of 8. Derivative of this is 5 times x minus 2 to the power of 4 times denominator, which is x minus 5 to the power of 4, minus derivative of denominator 4 times x minus 5 to the power of 3 times the numerator x minus 2 to the power of 5. Is that clear? So we can now write g dash x, we are doing only one half of it, is take whatever you can take as common. So we could take x minus 2 to the power of 4 and x minus 5 to the power of 3 as common, right? That leaves with x 5 times x minus 5 minus 4 times x minus 2, right? And here we have x minus 5 to the power of 8. Now this can be simplified and we can get here x minus 2 to the power of 4 over x minus 5 to the power of 3 times you could simplify this. 4x minus, 5x minus 4x is x. Minus 25 and minus a plus 8, right? So we have x minus 25 plus 8. So that becomes the derivative for x greater than 2, right? Which is equal to x minus 2 to the power of 4 over x minus 5 to the power of 3 times x minus 17. Right? So this is g dash x. Similarly, we could write f dash x as equal to negative of all this, right? So we have negative of x minus 2 to the power of 4 over x minus 5 to the power of 3 times x minus 17. Does make sense to you, right? So that is how we could get the derivative of this particular function. Now, you could also have a different approach towards this. So we can write the derivative as, let me write down the derivative of this function here. So we can say that the derivative of the function is indeed equal to, say, x minus 2 to the power of 4 over x minus 5 whole cube times x minus 17. Negative value, so we'll write like this, negative value when x is less than 2, and positive this, which is x minus 2 to the power of 4 over x minus 5 to the power of 3 times x minus 17 for x greater than 2. Right? Does it make sense to you? Now there could be an alternate approach to this solution, right? So let me mention here alternate approach. The alternate approach can be thought of looking into this particular concept. That if we have a function f of x equals to absolute value of x, then the derivative of this function is x over absolute x, where x is not equal to 0. And this could be written as signum x, correct? Where x is not equal to 0. Okay? So that is how you could actually write derivative of your function. So using this rule, right, we could actually find derivative and write an alternate solution. So let me write down the alternate solution right there in terms of signum function. So we could write p dash x as equal to, so the denominator here is x minus 5 absolute value to the power of 8, right? We are using quotient rule. Derivative of numerator, which is power rule first, 5 absolute value of x minus 2 to the power of 4 times derivative of this, which is signum x minus 2, right? Times the denominator, which is absolute value of x minus 5 to the power of 4 minus. Now derivative of denominator is 4 times absolute value of x minus 5 to the power of 3 times signum x minus 5 times absolute value of x minus 2 to the power of 5, right? So that becomes the derivative of your function. You can always simplify this, taking whatever is common, right? Some absolute value of x minus 2 to the power of 4, right? So to the power of 4 times absolute value of x minus 5 to the power of 3. We have this denominator here, x minus 5 absolute value of 8. And what you get inside is 5 times signum function x minus 2 and the absolute value of x minus 5 minus 4 times absolute value of x minus 2 times signum function x minus 5. Correct? So you could write your solution in this fashion. Yes, of course, you could cancel this with 5 and get a similar solution. So that becomes an equivalent solution for the derivative of the given function. Right? You can use Signum function. So I hope the concepts are absolutely clear. Feel free to write your comments and share your views. Let me get back to the original function which we started with. So what we really understood in this video is the absolute function, which, let me summarize, can be written as a piecewise function, right? So x when x is greater than 0, or rather equal to 0 also, minus x when x is less than 0. We also know that the absolute value of x is indeed equals to square root of x squared. We found that the derivative d dx of absolute value of x is x over absolute value of x, or signum x, let me write here, where x is not equal to 0, correct? So that was the derivative. So this derivative was here, written here. And the derivative, g dash x, when it is translated, could be written as x minus 2 over absolute value of x minus 2, right? So we know it is also not defined when x equals to 2, and could be written as signum x minus 2. Is it okay? SG. Now, for the power of 4, we found that the derivative could be written as h dash of x equals to 4 times, we just applied the power rule. And we found that this could be written as x minus 5 whole cube, right? X minus 5 whole cube, which resulted into the solution as 4 times x minus 5 whole cube. Do you see that? Since that is equals to x, absolute value x minus 5 to the power 4 is x minus 5 to the power of 4, right? And this was very interesting as we found that derivative to be 0. And this, as we showed you, could be solved using the Signum function or using the piecewise function. So I hope you understand and appreciate the approach. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.